This tutorial will provide an introduction to Multisim and discuss some of its features. The major emphasis will be directed toward an overview of the parts bins and how to place parts on the schematic. Later tutorials in this series will deal with the various features for constructing circuits on the screen and for simulating those circuits, as well as evaluating their performance. It should be noted at the outset that it is impossible to cover all the features. Most users will typically use only a small subset of the available operations inherent in the program. However, once you begin using the program, many operations will become clearer as you develop experience. For this demonstration, I am using version 12. However, most of the basic procedures covered should apply to other versions as well. As with the case with much software, there may be several ways to achieve the same final result. If you already have experience with some parts of the program, you may occasionally find differences in the way I implement a step and the way that you have learned it. This is to be expected because of the multiple steps involved and the different paths that can be taken. Finally, you can watch demonstrations of this type extensively, but the only way to really learn software as complex as Multisim is to actually work with it and try the various features that are present. You will make mistakes, most likely, but in so doing, you will learn how to perform the operations that you need. Now, in the dialog that follows, the term click will usually specify a single left click, and the term double click will specify a double left click. I will try to specifically use the term right click when that type of click is necessary, but I may occasionally slip on that convention, so be aware of that situation. Now, as you're looking at the screen, you see the way that this version opens on my screen, and you will see the pointer as I move it around on the screen. The first thing that one would do, unless you already have a schematic that you have saved, in which case you would go up to the file and find it and move it onto the screen. The first thing to do is to investigate the various parts that are available in Multisim. And that is a very, very large number of possible parts. I have never used more than a very small percentage, and I doubt that most people have. But the best way that I have found to get the parts, again, there's more than one way to do this, but along here you see various families, or parts bins as they're sometimes called. The first bin on the left, I want to look at that. You see the ground symbol, and when I click on it, what opens up is a list of parts bins and the various elements contained in each part bin is located along here. For example, the power source bin, we have AC power, DC power, digital ground, non-ideal battery, and so forth. I might point out this DC power is in fact a battery. So when you need to have a battery, you go to DC power. There is also an AC power. You will later see there is an alternate way to get a sinusoidal source, but this particular one is set up on the basis of 60 Hertz and an RMS, or root mean square value, of 120 volts. The ground, all circuits require at least one ground, so that will always be necessary to have a ground. And let me jump down here because in a later tutorial I'll be using a couple of these. These are four particular elements: VCC, VDD, VEE, and VSS, which each one has a bus and it's connected to a particular voltage that can be changed, as you will see in the second tutorial if you watch the second one. The value can be set and you can turn it around, and there's also a ground that's contained inside. You don't see that ground, but there is a ground. This is a bus in which there is a voltage with respect to ground. Now that's in the power source area. If I click on the signal voltage sources, I see a lot of different kinds of signal voltages. And the first one here is an AC voltage, which as far as I know internally has the same software situation as the AC power, but this one is more aligned to electronic type applications in which you set the peak value rather than RMS voltage. Then there's an AM voltage, amplitude modulated voltage, and lots of others that we won't try to discuss right now. We have current sources. We also have control voltage sources. Those are sources in which you have an output voltage that's controlled by either an input voltage, as this particular one is, or an output voltage that's controlled by input current. So you have the possibility of different control sources. Here is the one I just mentioned, the current control voltage source. And then you have current control, control current sources where you can control with either a voltage or a current. And you have digital sources and control function blocks if you're dealing with control system. If you click all families, all of these come up at the same time, and that can be a little overwhelming to try to find something in here. So it's probably better to look at each one individually. Now, if I get out of the sources area and look at the next bin, I see here basic, place basic. So if I click on it, I get a large number of different types of families here. You have virtual components and rated components, and three areas that you'll use extensively are resistors, capacitors, and inductors. In the case of resistors, with this particular version, you actually set the value up here to whatever you want. So for example, if I wanted a 1K resistor, I can enter that as 1,000, or alternately, I can enter it as simply 1 and K. Now, I'm not going to open that up yet. I'm just showing how to list the values. In the case of capacitors, you've got large numbers, but you can also set up a particular value up here. Inductors and lots of other components here as well. Now, let's go out of this one and go back to the next bin here is diodes. And you have large numbers of diodes, as you can see, that correspond to actual parts that are available on the market. Let's get out of that one, and you have transistors, and here under transistors you have virtual transistors that are ideal, but then down below that you have BJTs, bipolar junction transistors, NPN, PNP, we have MOSFETs, JFETs, and so forth. The next category is analog components. We'll be using op-amp in the second one. I'll click on that right now. You see the 741 is highlighted. That's a very popular op-amp. Let's get out of that. And as you go along here, you have the TTL family, many different families, many different components in that family. We have CMOS here. I won't show all these. And along here, there are lots of other types of component bins. Let me go back and just show how to pull these components out of the bin and put them on the screen. I'll use the resistor as an example. I think I clicked the wrong one there. Let's use resistor. Okay. I have the 1K. I'm going to go ahead and say OK on that, and a 1K resistor comes out. Let's say I want a 2K, 2000. Click on it, and it comes out. So you can keep pulling out. Alternately, if you have a whole series of resistors, you can actually highlight a given resistor and copy it and paste it on the screen and do it that way if you so desire. Let's go back and look at these two resistors and talk about some of the stuff that you can do with them. First of all, you can drag them around. If you take the button and hold it down, you can drag a component around on the screen, make it put it any place you want to. You can also change the value by selecting it. When you select it, put the pointer right up on it and click, and a box comes around it. And what you have done is selected that. And once you select it, you can make various changes to it. As a matter of fact, if you just double click on it, a window opens and you can change the value right here. If I want to change that to 1500 and just use the raw numbers, actually I went too far there, 1500, you can OK and it changes to 1500. Notice the ohm symbol there, the omega. You can also change the name of it. If I just click on, well, let's go back and click on the resistor again. There is a label here which you can type a new name in. If I wanted to change that to RIN, I can do that and click OK. You can also put a tolerance in there as well as a temperature coefficient if you look back at the window, but I won't bother doing that. What I will show you, though, is how to change the orientation. Now, I've talked about how to move it around, but suppose you want to change the orientation to vertical. Well, the way that I prefer to do it is to select it and then hold down Control and R, hit R, and it turns it 90 degrees clockwise. You can hit it again, a Control R, and it turns back around that way, and hit it again, it comes back vertically. You can keep doing Control R and rotate it 90 degrees each time you do it. There is no Control left. You really don't need it in a way because you can actually just do 3 Control R's for a component. You wouldn't have to do that with a resistor. But there is another way to do it, and that's to go up here to Edit and look at orientation, and here you can flip vertically, flip horizontally, rotate 90 degrees clockwise, rotate 90 degrees counterclockwise. So you can do it that way. I just prefer usually with passive components just to do Control R, and that usually does the job pretty quickly. But when you get into some areas such as certain components like operational amplifiers in the next tutorial, and you want to turn it totally upside down, you will need to go up to the Edit and orientation function. Well, that's a brief tutorial here on actually bringing the components down. I've only done resistors, but the same procedure applies with all of the various components. In the next tutorial, we will discuss ways of wiring up the circuit to complete a complete circuit.